In this video, we'll discuss tessellations. Now, tessellation is a tiling or repeating pattern of figures that cover a plane. The key is that there can't be gaps or overlaps when creating that tiling or tessellation. So here's three examples. Often you see this on floors with a tiling of octagons and squares. Here we have like a brick wall, and here we have an image that's made up of triangles. And in each of these images, you can see that they always are coming together with no gaps or overlaps from one object to the next. Now, when we're trying to create a tessellation, we can use one object or multiple objects. Just know that if you're doing a single object tessellation, it has to be a triangle, parallelogram, or hexagon as that foundational shape. To tessellate, the key though is that no matter what objects you're using, every time they come together at a vertex, they must sum to 360 degrees, whether it's one single object or multiple different types. Here is a regular hexagon where we know each interior angle is 120 degrees, and you can see where it comes together at that vertex. That's 3 120s, which is 360 degrees. Here, with that floor tiling idea, you had the octagon where each of those regular octagons are 135 degrees, and then the square was 90 degrees. And if I add these three values together, again, it's 360 degrees. Hence why they can come together perfectly with no gaps or overlaps. Now, we talk about creating tessellations around four different types of symmetry: translation, reflection, glide reflection, and rotation. And often once we see that there's reflection symmetry, that will lead to ability to create a glide reflection tessellation. When we do this, just remember that it's always important that there can't be gaps or overlaps when they're adjacent to one another. So here is an object that has been tessellated. It's a crazy design, but if we focus in on three, we can see what's really happening, and we can see that they're rotating around one another. This was most likely created using a hexagon and then using rotation symmetry to create the design. In this one, we have the reflecting birds, and this occurs by starting with a rectangle and then taking pieces from one side and reflecting them across to the other side, both vertically and horizontally. So if we continue to go down, we'd see that it would continue to follow that kind of flipping pattern, both left to right and up to down. Now, we have two typical types of special tessellations that we will discuss. Specifically, we have the regular tessellation, which is made up of a single regular polygon. There are only three regular polygons for which we discuss. That's going to be the regular triangle, in other words, equilateral, equiangular. We'll talk about the square because that's a regular quadrilateral, and the regular hexagon. These three objects will give us a tessellation no matter what when we put them together. And you can see how they fit together perfectly with no gaps, overlaps. Now, you can also construct semi-regular tessellations, and this is where you're using two or more regular polygons. For example, that's how we have the octagon and the square together. And here we have a hexagon, a square, and a triangle. So we're using those original regular polygons and then using them to make a new unique design. So we can create different shapes and options here as we go along. Now, if you want to create a single object tessellation, you have to start with that foundational shape, whether that's a triangle, a parallelogram, or a hexagon. You then need to determine the type of symmetry you want. If you're going to do a translation symmetry, you cut out the design from one side and then move it to the other side, and that'll allow for the horizontal or vertical translation. If you want to do a reflection, you cut out from one side and you flip it and move it to the other side. And if you want a rotation, you would take out and cut from one side and then rotate it around a vertex to another side to allow for that rotation ability. Once you've cut the pieces and moved them to other parts of your shape, you can then put down your shape and trace it. And then as you pick up that shape that you created, you can trace and move it and put it together like a puzzle piece until you filled up your entire screen or your entire piece of paper. So let's say we want to tessellate using this rectangle. So a rectangle is a parallelogram, therefore it can be a single object tessellation. So I'm going to do a translation, so I'm going to cut out from one side and move it to the other, and I'm going to do that left to right to start with. So I cut out this design here, and then I'm going to shift it to the right. Now I still have a rectangle, I've just moved apart, just kind of like using the moving principle. And now I could leave it like this and it would brick stack, or I can cut out from the bottom and move and translate that to the top as well. So now I have a design going up and down as well. If I wanted to do a reflection, I could have taken this piece and reflected it across this side, and then the shape would turn back and forth as it goes from one row to the next. So you can mix the types of tessellations as well. But once I have my translation created, I can now trace this and shift it left to right and then up to down. And you can see they always come together again with no gaps or overlaps. And now I have a translation tessellation on my screen.